Well, would you look at that? Isn't that the coolest thing ever? And it's so light too.
Buckle up for safety as I give you a day in the life of facilities maintenance.
Well, we've all heard the old adage, if at first you don't succeed, try again. And for some reason, if you look at this dimensionally, this turned out perfectly. My magnet drops right in there. You can see my pilot hole in the center. So that will secure exactly the way I want it to. Height, we are absolutely correct. But for whatever reason, and it looks like this because this just, you just chip this out of here. It breaks away because this plastic is laid down at 210 degrees and it's very hot, and you don't want the bottom to sag out of it as it's being printed. Anyways, this is supposed to be 10 millimeters wide and 20 deep. And for whatever reason, it's about 18 millimeters across. So I got to take a look at the file that was sent to me and just confirm the measurements. I thought they were correct, but obviously something's not correct. Yeah, so I just have to double check that and see why this is the way it is. However, other than that, this is pretty cool and light. Ultimately, yeah, this would replace that, and you can see the height is exactly where I want it to be. Yeah, it's great. So we just got to sort out what's going on here, and I'll be able to move forward. Okay, I think I found the error. Unfortunately, I can't edit. I can only view this file. But this is the recess in the bottom, and the distance is 9 millimeter, which is written in here. However, I believe it measures from the center axis, meaning it's doing 9 millimeter and 9 millimeter, which is why I'm ending up with 18 millimeter. So that would really need to measure 5 millimeter. I think 5 millimeter from the center axis will give me my 1 centimeter diameter. I actually think that is exactly what's happening. Yeah, I should have caught that earlier, but I didn't. And so, yeah, this is the way it goes sometimes. But I am glad that it's an easy solution. So, okay, next steps. Even though what we inputted this time was 5 millimeter radius for a total of 10 mil, what I am seeing here is 9.5 mil, which is why it just doesn't quite fit. Too bad. Okay, well, this is why we print prototypes. I predict. Third time is the charm. We are finally here. At the end of the day, we have arrived on a working model right here that will accept the magnet that I need and the stud that I need. First one we printed off on the 3D printer, we got the magnet side correct immediately, but inputted a wrong measurement for the bottom, so it came out twice the size that it needed to. Cut that in half, and it actually came out less than half. Instead of 10 millimeter, it came out to 9.5. So we increased this by 1 millimeter. This is actually now a 10.5 mil measurement. I actually haven't measured it. It's probably very close to 10 millimeter. And put a slight chamfer in the top, because what can happen when it's being laid down is just that the weight of the print itself can collapse the hole slightly, which is what we think has happened here and why this is actually slightly smaller than 10 millimeter. This size will work well. These are the correct length M6 bolts that I need. So I will simply epoxy that into place. The magnet will be screwed in right there. It's got the little pilot hole, and that works perfectly. I tested it on this one. When I start going into production of these, I'll print them in black so that it disappears up underneath here a little better. And yeah, I will be able to retrofit away and correct this issue that we've got with these chairs. So I'm noticing that it wants to lean over one direction. There it's straight. There it wants to lean over in a direction to the right a little bit there. I don't know if it's the head of the cap bolt that's slightly not square, or if it's the problem is down inside the actual 3D model that I have here. But just push it up against the bottom of the stand there and let it set up that way. That way it'll set up square and won't want to tip over in the direction that it wants to lean. Well, I think we're finally there. The last prototype I just had printed, I had it done in black because if this one works, then I'm just gonna throw it into the mix and use it. Let me show you what we did differently, and yeah, made a difference. So this prototype that's up here, as well as these two here, were printed in this orientation. This is the top, this is the bottom. And what ended up happening, which was interesting, is two things. When this is on the bottom, it compresses in a little bit. But another thing that happens is way down inside, that doesn't end up being perfectly flat or perfectly square. The issue there is that when I drop the bolt in, it's not coming out straight. It was coming out at a bit of an angle, which is why I had to lean the previous one that's up in the armrest of the chair right now up against here to just hold it straight. Where this, printing it this way, there's no compression that happens, or no sagging or anything that happens had it been printed this way. It ends up being nice and square, which is great because then I can just, with a little bit of epoxy, drop those in and they'll just set up on their own. I don't have to mess with them. What is different though is if you look at the roughness of this surface where my magnet is going to be attached to, this is rougher. So yeah, I'm glad I printed this in black because this is a usable piece. All right, I'll just let that cure up, and yeah, I'm pretty confident that that'll be very successful. Well, I think this is it. Still a little bit warm too. Reminds me of one of those center discs that, for those of you who are old enough to remember, you would put in the center of a 45 record to play on a full-size turntable. Well, since it's raining outside and I'd rather work on the roof leak issue when it's dry, I'm gonna switch gears and jump back into my chair project. So I've decided to make a small change here. As elegant as this round washer looks, I need more mass, more surface area than this. I need my receiver to actually extend beyond the edges of the magnet, because what I realized is when it's only grabbing a portion of the magnet, I'm not utilizing the full potential of the magnet. So this is what I'm gonna do. I'm gonna switch up the round washer for just a small plate like this. The strength difference is unreal, actually. To pull that off takes a lot of effort because it's actually utilizing much more than magnet. I cannot do that one-handed. I'll be returning these washers minus my one sacrificial washer up here, and I have to try and remove this. The good thing is that these are significantly more expensive than these guys. The tricky thing is getting this off, because if you ever wondered how effective epoxy was, I tried to undo the screw and literally twisted the tip of the screwdriver, so that's not going anywhere. I am probably going to have to cut this off. Okay, so a drill won't touch it. That is what it shall look like, and I expect outstanding results. Let's reassemble this table, put it back onto the chair frame, and see what kind of performance we get this time. Well, I'd say that's high performance now. You gotta fight it off. That's beautiful. That is kind of... yeah, this is next level. Yeah, it takes effort to separate it now. Oh yeah, it's so much stronger than it was before. So it's just the increased mass, the larger surface area of this metal plate extending beyond the edges of the magnet. So yeah, I've got it. This is what I'm gonna go with. My round neodymium magnet up in here, and just this little inexpensive metal plate right there. What a difference. It just locks on and it stays. It's there with force. Solve a problem like this, it's a good day. I enjoy my work. I enjoy many aspects of it. Being able to do something like this where it's a little bit more creative, really problem solving and pretty much literally inventing. Yeah, I love it. I appreciate you taking the time to watch. Thank you very much. Have yourself a great day.